Okay, so in this next chapter, we are going to focus a bit more on the object pooling concept. And we finally created a bunch of spawners that interact with an object pooler. And yeah, we're going to walk through that in this video. So this video will cover the pooling of the actors. We'll do that in the editor so you can see it live. We'll cover the data tables that we use to configure the individual spawners, so there's a level of uniqueness from one spawner to the next, which we will define in various data tables. Then we'll jump over and look at the performance results. So we'll look at the stat file for a packaged game both with and without object pooling, so we can see the difference between those two strategies as it relates to frame counts. And then we'll close with kind of a walk of the code, and I'll explain some of the core concepts. And then, of course, all of the code will be accessible via a link in the description. I do ask that if you are just going to simply download the code, please either watch the video entirety or like and subscribe it so that the engine or the algorithm can continue to advance our situation. All right, so in this video, we're going to talk about four basic areas. We're going to cover, in our last video, we covered the spawner, determining when we would activate and deactivate based on crossing the threshold of the spawner sphere component. In this video, we're going to talk more about the usability classes, how we idle and activate various pawns in the object pool. We'll talk about how we reset the AI logic back to a static state when you return something. We'll talk about how you reinitialize things when a spawner requests a new pawn. And then we'll hit a little bit on the basics of the animation, which is probably the most basic of our AI pawn experiences. And then in future videos, we'll build on that to have more and more complex AI pawns. But that should basically give us the overall coverage. All right, so let's jump into the editor and we'll look at sort of the results in action. Okay, so we're in the editor, and each of these icons on screen are actually a spawner. So let's zoom a little bit out. So we have a variety of spawners that are placed in the level. You can see them here as represented by these icons. And they are basically just copies of our AI spawner. And our AI spawner has a couple of parameters. So we added this new setup to use the object pooler. This is to allow us to separate from using the object pooler or not using the object pooler. It helped us do some performance testing, but it also is great if you have a very unique class and you don't want it in the object pooler. You could create sort of a boss spawner that had a very custom pawn class and a very custom controller. And therefore you would say, I don't want to use the object pooler. I want to use a very specific pawn and a very specific controller, in which case they would be spawned and despawned normally. However, if I say use the object pooler, then they're going to get recycled. We added this data table, which is new from our last video. This is where we set up the various aspects of what we're going to spawn. So in our previous videos, in the individual spawners, we configured the pawn information. What we've moved to is, instead of having the individual array in every spawner, if you think of a scenario where you might have a bunch of trash mobs and there are 5 or 6 of them on a map and they're all exactly the same, you don't want to have to go through and configure each spawner every time. So instead, what we've done is we've created a data table. And you can see them here in our content browser. And so I have a data table, and that data table says how many pawns am I going to spawn? And then for each row, where do I want to spawn them? So what's the offset? What mesh do I want to spawn? What anim blueprint do I want to use? Do I want to have it apply some random animations? Should it enable collision? Should it have a spear trace? And should it have a controller? And if it has a controller, should it have a behavior tree? So for each row in the data table, we can configure the aspects of an individual pawn. And therefore, by assigning this data table to a spawner, so let's go and pick one in the outliner. So spawner 1 is going to use the spawn Johnson data table, whereas spawner 8 is using a different data table. So each of these will spawn the actors in accordance with the data table. So it's probably easier if I just show you. All right, so let me press F8. So this group is one spawner, and that spawner spawns all 8 actors, and those 8 actors, oh, hold on, do that again. All right, so F8. Yeah. So these actors are all part of one spawner. And the data table defines which mesh, where they're going to be located, and what actions they're going to perform. So that's a group of one spawner. This is another spawner where there's a single actor performing a repetitive loop of what they're doing. Here we see another spawner, and they're performing actions in unison, and more and more. So let's look at both the, what I call crew 2, and the Johnson data tables. So the data table crew is the one we saw on the far left, and it has a variety of meshes. You know, this one is variant C, variant B, and variant A. And you can see that they are positioning themselves in a variety of offsets in the XY coordinate system. And that's what creates the shape of that group, right? So the one is in the center, and there are 2 offsetting 150, 150, et cetera, et cetera. Each one has their own anim blueprint, and each one is inserting a random montage every 5 seconds. So by setting all of them equally to 5 seconds. You see that all of them are at 5 seconds. And they all play the exact same montage at 100%. So all of these are set every 5 seconds, play this montage 100% of the time. That's why when we hit play, this group over here performs in synchronization because their frequency and the 100% occurrence means they will all do the exact same moves at the exact same time. If I were to change that, and let's say 3 seconds, and this one is going to go 4 seconds, but only trigger 50% of the time. What you'll notice is the group is no longer in sync because the lead character only triggers 50% of the time, and the character in yellow, I forgot what I set, but does something totally different earlier, starts earlier. And so that group is no longer in sync. Let's go ahead and set that back. So the lead character is at 5 seconds. This character is also at 5, 5, correct. And they need to go at 100%. So when that spawn group comes in, they should be synchronized again. Perfect. All right, so in this group, you'll notice they're spaced out, following the same routine, except the closest to us is facing a different direction. That is crew 2, where each character is spaced out accordingly. However, the sort of conductor has a rotation of 180 degrees. So these are all rotation of 0. The last character is rotation of 180. They are also ticking every 6 seconds, and they are playing 100% the same animation, which results in this kind of a pattern where the one character is facing inward to the rest of the characters that are facing outward. All right, so we have the single character here that's doing a backflip. We won't spend a lot of time on that one. Here we have a mixed group where some are stationary and some are executing different animations. So let's go back to that group. So some of this group is stationary, and some are going to perform different animations at different times. And that's because the mixed group, has different times and multiple animations are going to run. So every 4 seconds, this character will wake up, and 20% of the time it will do a backflip, and then 10% of the time it will do the wave, and the other set of times it will do nothing. And so each of these characters, this one has none. So none of them are set up. This one says every 7 seconds, I want you to wake up. And 100% of the time, you're going to do the Gangnam Style. So this one wakes up every 7 seconds. And every 7 seconds, they will do this animation. All right, and then let's run around the map to watch people spawn in and spawn out. So you'll see these trace lines, which we'll talk about in a minute. There you see characters coming in, doing what they need to do. As I look back, certain characters will spawn out the further away I get. And then as we move around, characters will come and go based on where I stand in their overall spawner. So that group just showed up. If I go up the hill, you'll see more people showing up. Note that they are at different heights based on the terrain. So this was a test to make sure that if I spawned characters in on a terrain, that they would show up at the right level. Now, they're not doing foot IK yet, but they're not sitting on a flat surface. So unlike these, which are on a flat surface, you won't actually see that behavior occur. But if I move over here to this rock and spawn in another group, they're all going to be at different elevations, and that's okay. All right, so what we're going to do now is turn on the logs so that you can see how throughout the code we have a variety of log points just to debug and see how the object pooler is working. So I'm going to turn them all on. So I'm going to turn on the spawner subsystem log, set it to verbose. I'm going to set the spawner to verbose, and I'm going to set the pawn. So now all three of those, and then I'm going to go ahead and you can see the pawn determining whether or not they should trigger their random montage. Let me clear that. And move over here. Oh, I'm down here. All right, and then as the character moves around, you'll see that it is going to perform a variety of things where it's checking new objects, it's checking the, determining the trace location, and then you'll see it returning pawns back to the spawner pool. Let me get up here and spawn a few more in. All right, that's probably enough data for us to take a look at. So I'll stop. And then if I filter this list, here, let's make this full screen, to just the spawner, so here's the subsystem, and you can see it issuing pawns and controllers and then receiving them back. And so it's here you see that we issued enough that we needed another block of 10. So we now have 10 available, and then we issue. Here we ran out of controllers, and then we continue to issue controllers and pawns, and then we need more, so we issue some more, etc., etc. So the object pooler, and then here's where we shut the world down, and it shut it down. So the spawner subsystem is giving us those messages. The pawn is giving us messages when we're checking whether or not we have the montage to play. Here the pawn got issued from the spawner, and then here you see us calculating where the ground location needs to be from that line trace. Here you see us setting a skeletal mesh. Here you see us issuing another controller, etc., etc. So throughout the code, there's a lot of places where you can enable the logging to see how the object pooler is working. And of course, you can always look in the outliner. So if I open the outliner and start by just filtering that down to pawn, you see I don't have any pawns. I have these spawners, but I don't have any pawns. So maybe a better way to put it is AI pawn. Okay, so we only have one AI pawn, but when I hit play, you'll see that our AI pawns were spawned in and our controllers were spawned in. And then as I move around, actually I gotta pin that. Pin this list, you should see it grow as I need more. There you saw it grow and grow. So our object pooler is up and running. This means that as I go around now, we're recycling objects and not needing it. Note there's no green arrow this time because they're being recycled. It's not the first time they're being placed. And everything seems to be working just fine. Okay, so this is the session log from spawning. And you'll see at this line down here is 60 frames per second. And this is 20 frames per second. And this is 30 frames per second. So we're floating between 30 frames per second and 20 frames per second. And as I scroll across the bar, you'll see that we move up and down between sort of 30 frames per second and then up to 20 frames per second and then back down to 30 frames per second. And just sort of follow that pattern. Now let's compare that to our object pooler. And as usual, we start up. There's a spike upon startup. And then you'll see the 20 frames per second here, the 30 frames here. And as we scroll across, you'll see that we're staying closer to the 30 frames per second and not touching the 20 at all. So you'll look through here, you see a lot less variability in the graph. It's not swinging nearly as many spikes as I spawned in and out through the object pooler. So it's much flatter through this period than the other one where we had a lot of spikes. And then of course we have a few little spikes, and then here's where we shut down the instance for the game. So the net result is a much smoother line through here in comparison to the, let me load the other one up. We go back to loading the, so you can see the difference. Whereas in this log file, you see a lot more spikes and valleys as you move through the spawn cycle. So hopefully that helps. All right, let's walk through the C++ code to see what's different from the last video to this video. Again, as a reminder, the code is attached in the description, so feel free to explore it on your own. So we're up to 4 classes now. We have our pawn controller, which is new this video, spawner, and spawner subsystem. The pawn controller is simple, so we'll just talk about that very quickly. Similar to the pawn, we're inheriting from the modular AI controller that gives us access to the modular systems, and that can be useful. But all we have in it right now is the constructor and a wake up and sleep routine. These are the C++ ones that are called. They in turn will call their blueprint equivalents here so that you can further extend in Blueprint. So it's basically just a shell at this point, because we haven't done anything with the controller yet. And of course, the constructor is simple. We don't want it to tick, and we don't want a player state for our for any AI that we create, unless of course we decide that later. But right now we don't need a player state, so we're saying no to that. And in our wake and our sleep routines, right now we're just calling the Blueprint function, but we'll flesh those out later. So those two classes are new, and they're quite simple. The pawn is sort of the workhorse. So let's talk about the pawn a little bit. So we've got our log categories. We inherited from Lyra pawn. It was the same as last time. We have our 4 components: the root scene component, the skeletal mesh, the collision, and the generic sphere. We have a couple of private variables where we cache the pawn info. We have a handle for our animation timers, and a handle and a pointer for our controller. We have our constructor. We have the same logic. We wake and sleep, and we have corresponding Blueprint nodes for waking and sleeping, and we have 1 extra pawn initialized, which is something we're playing with for non-pooled actors, but those are the basic functions in the pawn. So let's go to the bulk of the logic here in the pawn. So constructor, don't enable the AI controller by default. Here's our scene, here's our skeletal mesh, here's our capsule and our sphere, and then we sleep the eye. So upon construction, the first thing we do is put the actor to sleep. And then let's do the wake up. So when we request the pawn to wake up, we're going to give it the pawn information and the associated spawner. We'll cache that right away so that we have a copy of it internal to the pawn for future. If this is the first time through, we're going to perform some calculations to determine where to spawn the pawn in relation to the spawner. So the spawner can have multiple pawns associated with it. And if this is the first time the spawner is asking us to initialize into the world, what we're going to do is we're going to figure out where to put this. So we have an offsetting location X and Y. So we grab the associated spawners X and the associated spawners Y, and then we add our offsets X and Y. So right now we have a vector that has an X and a Y, but no Z. So right now we're just figuring out on the plane, where does it sit relative to the spawner? This basically does a line trace. So these codes start with a line trace above the character location on XY, and then shoots a line straight down below and determines when do we intersect with a visible channel. So when do we hit something, be it a rock, a ground, landscape, mesh, whatever we hit, that's going to be the Z location for our pawn to stand on. Just make sure our feet land on uneven ground. Now, we're not doing foot IK yet, but this allows us to place the actor on uneven terrain. So once we do all of that, we get our hit location, and we basically save this as our last transformation scene. This is for the future where we're going to pick it up. So we do this once, we set the actor to that location, and then we turn that flag off. So for the next time, we're simply grabbing the last transformation scene. So it's set here for the first time. If the actor moves, we'll update this so that when we pick it back up, we don't have to go through this math again. This is just enabling the collision, enabling the sphere, setting the skeletal mesh up, setting up the anim class, obviously making sure the skeletal mesh and the anim class are of the same skeleton. That's up to you to do. We're not doing any checks on that. And then if we've asked to insert random montages, then we'll kick off a timer at set frequency. So this is going to tick away every couple of seconds, whatever you set in the data table, and fire off to determine whether or not we want an anim montage to play. If we want a controller, here's how we get the controller. either from the object pool if the spawner is using the object pool, or spawning into the world if the spawner is not using the object pooler. And then we possess this pawn and wake up our controller. We haven't finished the behavior tree. And then finally, we call our blueprint wake up AI to finish any logic that we want to do inside the blueprint. So that's the wake up. This is just how we get our montage. When we sleep, we basically sleep everything because we have no idea what the spawner was doing with this pawn before they gave it back. So when we sleep this pawn, we'll turn off the anim class, the skeletal mesh, we'll make it invisible. If we had a ticking timer, we'll clear that. We'll turn our collision off, we'll turn our sphere off, we'll dump our controller. If we had a controller, we'll either return it to the pool or just get rid of it. And then we call our sleep function. So those are the two main wake up and sleep routines that are in the pawn. The spawner, I don't think changed much. Let me take a quick look here. I gotta go back up here, sorry. So we have our enum, we have our random animation struct. Then we have our main information, which is where we get the spawn offset, the rotation. This is now inheriting from a table row base so that we can create a data table off of this structure. So basically this structure, because we added this, will now be able to create data tables from. And all this information will appear in the data table, what type it is, the skeletal mesh, the blueprint. We'll see that all in the editor, whether or not we want collision, whether or not we want the sphere, and then the internal variables, which will not show up in the data table because they don't have the U properties, but they are still part of the structure when we're using it. We did that in the last video. Those are the same. We added a billboard and an arrow component just to see it in editor. So when we're in the editor, much like the character, we can see rotation. Whether or not we're using the object pooler, what pawn class and controller class do we want to use? If we're using these and the object pooler, they have to be consistent. We'll talk about that in a few minutes. The radius, the debug, that was all the same. These are the two ground offsets. So starting 1,000 centimeters above and then going 1,500 centimeters below the spawner Z location. And that's just the array. We copy from the data table into this array so that we can manipulate the data while the spawner's in the world. That's the same. Those are just two new functions, and the rest of this, I think, is all the same. Yeah, so the rest of that is all the same. So that's the pawn and the spawner, which again, I don't think there's anything major other than adding this visual element to the spawner so we can see where it is in the world. And then the rest is in our subsystem. So last time I think we initialized and deinitialized, but that's about all we did. Now we have two integers, the incremental pool size. This is how we will grow the pools as we need more and more pawns or controllers. And then if we have ourselves in a situation where we have an overabundance, in other words, we have over 100 of them available, then we'll shrink the pool down based on that. These are our pools. So we have an idle set of pointers and an active set of pointers. We do the same for the controllers. So these are all available to be handed out. These are out there in the world, and we just use that as sort of a reference guide to know how many are in the world. The main routines are requesting an AI pawn, and this is where we pass the class in, and return the AI pawn where we pass the pointer back. So here we request a pawn and we'll get a pointer to the pawn. Here we'll return this pawn and we'll put it back into the pool. And same thing for the controller. So these routines are consistent. On initialize, we're just reserving some capacity so we don't have to keep increasing the array size. When we exit, a world, we just clean up any actors that the pool has. So upon deinitializing of the subsystem, we get rid of all of the potential pawns or controllers in these arrays. All right, and here's the request. So there's the request. The request says, all right, just in case you fail to pass me a pawn class, I'm going to default it to this so we don't crash. So this, you should always pass the pawn class. This is just sort of a check to make sure we don't crash. The first thing we check is, do we have any available? If we have no pawns available, then I need to allocate another batch. And so what will happen is we will allocate another, in our case, 10, because that's set to 10 right now. We will spawn those into the world, and we'll put them to sleep, and then we'll add them to the idle pawn list. So this will add 10 new pawns to the idle pawn list if the idle pawn is empty. Then after we do that, or we skip that, we then grab the very last one off the end of the idle pawn array, add it to the end of the active pawns, and remove it from idle. So that basically moves this actor to the active stack, removes it from the idle stack, and then sends it to whoever asked for it. So they issue it through that return node. The controller works the exact same way. Then upon return, so when we return an AI pawn, first we check that it's valid. If it is valid, then we're going to remove it off of the active queue, put it to sleep, and then add it to the idle queue. And we saw the sleeping and waking routines in the pawn. Then if the array is getting too big, so if the number is greater than my max, then what I'm going to do is I'm going to trim off from the end. I'm going to take, let's say the max is 100 and this is 10. So I will say from index 90 to the end, go ahead and deactivate or destroy those pawns, and then remove them from the idle pawn. Now, the reason we're doing this in 2 for loops is that while the remove at swap is more performant, it does not maintain index sequence, and therefore it's safer to sleep all 10 pointers first, then go ahead and remove the 10 pointers so that we don't worry about the index not being consistent. And that's it. And then we have the request for a controller, which is the same, and a request and a return of the controller, which is the same. So that's the code. Hopefully it's helpful. Again, it's in the description if you want it. Leave a like or a comment, and let us know how we're doing. Thanks.